Hi everyone. So today we are going to discuss about the tutorial number 3. Um, so last time we have discussed about the bases and dimensions. So similarly, we will discuss the same thing here as well. I don't know why it's not working. Wait, I think I need to charge my laptop. So just recall what you have done in the last time. It's working now. So we have discussed about bases. So what is a basis of a vector space? So if you have a vector space V, then basis is linearly independent and I think it's not working on this side. Subset of V that spans V, right? So that is the definition of a basis, and it looks like say S. If S has V1 V2 up to Vn elements, then you say that n elements. Sorry, it's not working here. So what's the cardinality of this set? Then it's called the dimension, right? Yeah, and I think I can use this. I don't know how to make it clear. Maybe it works like this. Uh, yes, it's hard to figure out on this app. This app is new actually, and I'm using this. So this is the dimension of your basis. Okay. Don't think so. How to get into? So let me use another app for the time being. So please wait for that to charge my battery as well. So just recall the dimension and try recalling the questions that you have done before, right? So I will be discussing that. So let me stop screen sharing. Please wait. Just wait for some students to come. Just wait for a couple of seconds so that. So let me screen share again. Wait. I think there is like share screen team as well. Yes. So I just go there on the and a new note. Yeah. So tutorial 3. So I was charging my pencil and then I discussed this. Okay, so maybe I can discuss in this way if that is fine for us. Yes, so I have discussed the what is basis and dimension in the last tutorial. Now we try some questions based on that. And in the third tutorial also we do have the same kind of stuff. Let me see. So the first question is, consider the vector space V of all 2 by 2 real matrices with zero trace. Then dimension of V is. So you have a vector space of all real matrices with zero trace. What does it mean? Yeah. So let the space be like this one. V is all M all. So A belongs to M2 by 2 over R such that trace of A is 0, right? So you have to tell what is the dimension. So I'm recording. So just try this question for 5 minutes. Okay, just try this one for 5 minutes. Yes, what's the solution for that? So since A is in, so I just use a different color, maybe a green color. Since A is in M2 by 2R, so what does A look like? A will look like A, B, C, D, where A, B, and C, D are from R, right? And this is a given condition that trace of A is 0. So it implies that A plus D is 0. It implies that A is minus D. So we have this type of thing, A, B, C minus A. That A, B, C are in R. So what's the dimension? What's the dimension of A? Which set spans A? So the set spanning the set A is this. So just take this one, and this set spans A, right? And you can check that this set is linearly independent as well. So dimension of vector space is 3, right? So this is very clear, like how to find the dimension. You have to put the condition over the matrices and then you get this. So we do have next question in our list. So there is a next question which says that, so now I want to tell you about what is a linear transformation. So linear transformation, say T is linear transformation if T is a map from a vector space V to W, where V and W are vector spaces. So these condition, first condition is TA plus B is TA plus TB, AB belongs to V, and second condition is T alpha A is same as alpha TA, alpha belongs to F, where the field. So these are two conditions, so we say that T is linear transformation in that case, and from this you can conclude that T0 is 0. So you have to use this fact to check. Okay, now I just write, wait, I just write the question, let T from P2 to M2 by 2 is linear transformation such that T1 is 1001, Tx is 1101, and square is 1 1 1 1. Then what is t? 1 minus x square. So you have to find this value. So try to use this property of the linear transformation over here and try to find out the value of t. Okay, using that, use the linearity. Okay, just try that. Yes, so we try this now. So how do you find out the solution in this case? So t1 minus x square can be written as t1 minus tx square. Which property I used here? This one, the first one. Then you just substitute what is t1, which is 1001, what is tx, which is 1101, what is tx square, 1111. So 1 minus 1 is 0, minus 1 minus 1, 0 minus 1 is minus 1, which is minus 2, and 0 minus 0 is 0, minus 1 minus 1 minus 1 minus 1, 1 minus 1 is 0, minus 1, which is minus 1. So you get this type of result, which is directly using the property of linear transformation. So that's simple. So we are going to try another question. So we have another question that which of the following is not a linear transformation? So the first one is t from R2 to R2 such that t is dxy is x minus y. So is that a linear transformation? So we are going to check everyone one by one. Just try TCR, set of complex number over R to complex number over R. TZ is Z bar. Z bar is complex conjugate. T from Mn cross Mn by N over R to R. T of a matrix is determinant of a matrix. T from set of polynomials over R to R. T of R0 plus R1x Rn xn is Rn. Just check. Just check whether they are linear transformation or not. Just take 5 minutes. So we just do that. So TR2 to R2, the first one is Txy is x minus y. So T0 is, so how do you check it is a linear transformation or not? Do you just take x1, y1 and c1, d1, then you just check is it same as tx1, y1 or t1, c1, d1? So is it true? So we have this, so you just write this is same as this, which is same as this, and right hand side is tx1, y1 plus tc1, d1. So tx1, y1 is x1 comma minus y1, c1 comma minus d1, which is same as x1 plus c1 minus y1 minus d1. Okay, so which is same as this. So both of them are same. And next step is to check that T alpha of xy is same as alpha txy or not. So T alpha xy is T alpha x alpha y, which is same as alpha x minus y. Alpha x comma minus alpha y, and same as alpha x comma minus y, same as alpha txy. So it's true. So first part is linear transformation. So we will be discussing only these concepts today. The another one is this one, which is z equals z bar. So dz is z bar. So you take any complex number a plus ib, which is same as a minus ib, where ab is in R, right? So ta plus ib is same as a minus iota b. So you take any complex number than this. So let's check the second property first. So alpha a plus ib is same as alpha a plus I alpha b, which is same as, so this is alpha a minus I alpha b, which is same as alpha a minus ib, which is same as alpha t a plus ib, right? That is the thing. So the second property is satisfied. What about first property? You take any complex number z1 plus z2. Then what is z1 plus z2 bar? But it is it can be distributed. Then you can say tz1 tz2. So first property is also satisfied, right? So this is true. Next question is Ta is determinant of A, Mn cross and matrices. So third question is T of A is equal to determinant of A. So if you have n by n matrix, what is, so T of alpha A, is it same as alpha T in this case? Means, so let's try it. Take A to be identity matrix I2 I2, which is 1 0 0 1. Then what is 2 times I, which is same as T of 2 0 0 2, which is same as 4, and T of I is same as 1. So T of 2I is not same as 2 times T of I. So second property is violated. Okay, so T is not a linear transformation in this case. Okay, and fourth one is, so you have to find the counter example when T is not a linear transformation. So PNR to R, where R0 plus R1x plus Rnxn is Rn. Okay, T of R1 Rnxn plus Rn minus 1 xn minus 1 R0 x naught is same as Rn. Is it the same? Right. Is it a linear transformation, it seems like, or not? That's true. That the second property is first. Second property is true, but what about first? What about the first one? Okay, let's try this. T of x plus 1, which is 1. T of minus x plus 1, which is minus 1. But T of 2 is 0, which is same as 1 minus 1. Yeah, so I think so. You take minus 2x, and that will be minus x. So T of minus x will be minus 1. I think it is a linear transformation. Let's check. Okay. Okay, let's check. So you take any polynomial like this one, Rn xn plus Rn minus 1, gamma n xn plus gamma n minus 1 xn minus 1. Then it is same as Rn plus gamma n xn R naught plus gamma naught x naught. Then you get gamma n Rn plus gamma n. So this is same as Trn xn. Yes. So that is a linear transformation. That is a Another thing is, yeah, that's true. So think the third one is not a linear transformation. Third one is not, otherwise all are linear transformation. So let me check. We have another questions similar, but if this is similar, then I won't be doing that. So we have discussed about the linear transformations and bases already, dimension, bases, linear transformation. So almost all the questions have been covered. So if you have any doubts, then you can ask for 10 to 15 minutes. So all questions on linear transformations, bases, and dimensions are covered. Any questions, just ask.